Hi, I'm Ruben Iglesias, and I will be presenting private VLANs as part of the CX 10.8 update. Our agenda is an overview, use cases, specs and caveats, configuration, troubleshooting, and a demo. We'll start with the overview. A private VLAN is a technology that allows us to take a VLAN and subdivide it into smaller pieces and to create layer 2 microsegmentation. And that can be done at the port group level or at the port level. And we will get into the difference in a few minutes. One interesting aspect of private VLANs, and one of the main reasons behind private VLANs, is that all the ports inside the VLAN will have the same VLAN interface. So they will have the same external connection to other subnets, and everything within that private VLAN will be part of a single IP subnet. Let's start with some definitions. The primary VLAN is the main VLAN that we will subdivide. The secondary VLANs are those subdivisions or sub-VLANs. And the first thing that you need to know is that there will be no traffic between secondary VLANs. Secondary VLANs can be of two types: isolated VLANs or community VLANs. The PVLANs will define some port types, and some ports will be secondary ports, and those are obviously the members of the secondary VLANs, either an isolated or a community VLAN. A promiscuous port is a member of the primary VLAN, but it's not a member of any one of the secondary VLANs. And what we just said applies both to a port or a link aggregation group. Some additional notes: as we said before, the VLAN interface is the same for all the ports, and it is part of the primary VLAN. So you define the VLAN interface for the primary VLAN, and it becomes the VLAN interface for all the secondary VLANs. The HCP is supported on all ports, and port security, applying AAA radius, .1x, MAC authentication, etc., works on all ports independently of the type of secondary VLANs they belong to. Here's an example of the dynamics of private VLANs, and just notice that I will use only a few of the possible connections, just to keep the diagram simple and not too crowded. But what I will say applies to all the ports that we see here. So we have here two isolated VLANs and two community VLANs, and then outside we have the primary VLAN that includes them all, and it includes a promiscuous port and the VLAN interface. And I'm representing here with the orange dotted lines connections that do not work, and with the full green line connections that do work. What do we mean by that? So ports inside the isolated VLAN cannot talk to each other. However, ports on a community VLAN can talk to each other. However, between sub-VLANs or secondary VLANs, there is no communication. So a port on a community VLAN and a port on an isolated VLAN cannot talk to each other, and the same thing applies between two different community VLANs or two different isolated VLANs. However, all ports can connect to the promiscuous port independently of what secondary VLANs they are located on, and they can all communicate to the VLAN interface. So all of that is summarized on the table on the right. So ports within the same community VLAN can talk to each other. Ports within the same isolated VLAN cannot talk to each other. Inter-community VLANs there's no communication. Inter-isolated VLANs, there's no communication. Isolated to community VLANs, there's no communication. Any port to promiscuous port can communicate, and any port can communicate with the SVI. Let's take a look at how this can be applied. The first thing is, what do you do if you want to extend the primary VLAN, for example, in a typical two-tier layout in which you have a layer 2 access and you have either a collapsed core or an aggregation layer there where you have the VLAN interfaces. So the device at the top is where we start routing, and all the devices connected to the layer 2 access will have their default gateway on that SVI 100 in the collapsed core or other VLAN interfaces that you might have there. So the interesting thing here is that we want to avoid having to extend the secondary VLANs, and so we will just take the primary VLAN and extend it between the two switches and have it defined on the top switch where we have the VLAN interface, because that's the typical deployment. So in this case, the only thing that we do is we take this link between the two devices and we define this as a promiscuous port for VLAN 100. So it is a promiscuous port, and it will be connecting to the top switch. So one thing that you need to remember is what happens to the VLAN IDs of packets that reach the switch with a VLAN 101 or through a port on VLAN 101 or through a port on VLAN 102. What will happen is that as soon as they get in the switch, they will be tagged with their corresponding secondary VLAN tag or ID. Now, when they get to the port, the promiscuous port, because the promiscuous port is defined for VLAN 100 for the primary VLAN, those VLAN IDs will be replaced with the VLAN ID 100. So when the packet arrives at the top switch, the VLAN ID for those packets is going to be 100. So they will be taken straight to the VLAN interface and routed to the rest of the world. And the same happens with a packet coming in through the top. It will be routed through the SVI into the VLAN 100 primary VLAN, and then depending on the destination when it reaches the layer 2 access switch, it will be retagged as VLAN 101 or VLAN 102 for internal processing, and then it will depend on the type of ports that we have down here if the packets will be tagged on upon transmission or not. But the key again is all traffic from primary and secondary VLANs is tagged with the VLAN ID 100, the primary VLAN's ID, when it is transmitted across a promiscuous VLAN or a promiscuous VLAN port. There might be a situation in which you want the primary and secondary VLANs to be extended across a link between two switches, and in that case, you will not be defining that link as a promiscuous port. You will just use a normal VLAN trunk. You will allow VLAN 100, but because it's not promiscuous, that VLAN ID change replacement is not happening. In that case, you have to configure all the secondary VLANs on the other switch. So they both need to exist on both switches for this to work. But the VLAN ID from the primary and the secondary will be preserved and will be transported across the link. So now VLAN 101 will be extended across, and VLAN 102 will be extended across that link between those two switches. Some use cases. Let's start with some campus use cases. And again, we have isolated VLANs and community VLANs. Isolated VLANs can be used, for example, for hospitality, where you have in the guest rooms, you have wired connections, and suppose that you have only one of them per room. In that case, you want all of these ports to be isolated from each other. So you create a single isolated VLAN, uh, probably per floor or for the whole hotel if it's a small hotel. And then all of that gets into the primary VLAN where they are either routed or they can reach some servers, some internal servers for example, to order something from the front desk, etc. Now, community VLANs are used when you want to isolate groups of ports. So in that case, think of a shopping center or a shopping mall where you have small shops that have more than one wired connection, and you want to have the whole shopping center with a single IP subnet. In a data center, you might use isolated VLANs to avoid having to create ACLs when you deploy a physical backup network, and also for secure virtual desktops. You might want to use community VLANs when you have a multi-tenant data center and each tenant has many devices and many applications running, but you don't want them to be communicating with each other. One important thing about data centers is that private VLANs are supported on many hypervisors. In some of the examples that we have shown above, where we had these two switches, the access switch that you saw in that diagram could be replaced with a hypervisor. So you could have that server extending using a promiscuous port to extend the private VLAN to the top of rack or leaf switch. Let's take a look at some specifications and caveats. First of all, the supported platform for private VLANs in 10.8 are the 6200F switches, 6300F and M switches, 6400 switches, and 8360 switches. In terms of scale, the maximum number of primary VLANs are 32, secondary VLANs per primary are 24, and the maximum numbers of physical ports in a private VLAN are 24 for all switches, all models. Some details on the operational state. If the primary VLAN is shut down, all the secondary VLANs will be down. And if you do the show command, you will see that the reason will be shown as pVLAN primary down. If a secondary VLAN is shut down manually, but the primary VLAN is still up, the shutdown command will be ignored. If a certain secondary has not been associated to a primary VLAN, then the secondary VLAN will be down, will be kept down because it's not part of a primary VLAN and cannot function. Finally, for this part, there are some restrictions and exclusions. So for example, if you look at the bottom, pVLAN cannot be enabled when, for example, you have VLAN translation and GVRP configured on the switch. So it's a global mutual exclusion. Then you can go through this in detail by taking a look at the presentation, the slide deck. But there are certain restrictions in terms of promiscuous ports, isolated ports, and community ports. Configuration. The configuration of a pVLAN is extremely simple. We create a primary VLAN as a normal VLAN, and then we add the command private VLAN primary. I recommend that you use good names for these VLANs because that will help you when you visualize and you troubleshoot private VLANs a lot. So to create secondary VLANs, what you do is you create the VLAN, and then you add the private VLAN, and then you say either community or isolated VLAN, and then you add the primary VLAN. So that's the VLAN, the primary VLAN association. So secondary and primary VLAN association. Then on the right, you see what you have to do with the secondary VLAN ports. You would qualify them as private VLAN port type secondary, and that will apply both to ports that belong to a community VLAN or to an isolated VLAN. If the port will only be part of the primary VLAN, then you say private VLAN port type promiscuous. And you see that the allowed VLAN here is 1100, which is, so this port will belong to that VLAN, among other VLANs in this case. Finally, if you want a regular VLAN port uplink to be able to extend your secondary VLANs across, the only thing you do is you allow that VLAN in the trunk. However, you do not add the promiscuous port definition. The VLAN interface is very simple. Just remember that you apply that to the primary VLAN, and there's no way you can apply that to a secondary VLAN. It will give you an error if you try. Local proxy ARP. Proxy ARP will allow you to break the isolation between ports in a private VLAN. So it's not used in too many cases, but if you have to use it, you just apply the IP local proxy ARP command to the VLAN interface. But you also have to turn off IP ICMP redirect globally on that switch. Some troubleshooting. Of course, you start by determining what is not working, and based on that, you go through the configuration commands and try to find, for example, if you have wrong VLAN associations, if you have a secondary without the primary, etc. Or if the secondary VLAN is connected to the wrong primary VLAN. Port types, for switch-to-switch links, make sure that if you have the primary VLAN defined on both switches, that they're both either promiscuous or they're both regular. Just check that. And then check for inconsistencies. There's a nice command to show private VLAN inconsistency, and it will allow you to explore a little bit more of the associations between primaries and secondaries, but a lot more. So for example, it will show you if you turned off a secondary VLAN without turning off the primary, etc. So any inconsistency will be shown with that command. Finally, you may have to debug the local proxy ARP, and in addition to that, you can check the events and debug logs. You can check the ShowTech pVLAN and gather all the information related of pVLANs, or do a diagnostics dump for pVLAN. The ShowTech pVLAN and the diag dump pVLAN provide similar results or similar output. So checking the private VLAN configuration, that is very simple. You say show running config private VLAN, and it will show you everything that has been configured in that sense. Show commands, other show commands, show private VLAN association, and show private VLAN port types. And this is where what you would do to check that you have the promiscuous definition at both ends of a link if you extend the primary VLAN across. Show primary VLAN inconsistency. Here you have a list of the possible inconsistencies that you may encounter. And here's an example. So I created the VLAN here, 1130, but I didn't associate it with a primary VLAN. So the show private VLAN inconsistency command tells me that it is down. And the reason is that the VLAN has no primary associated VLAN. And if I go back to show running config private VLAN, it will show me that the command that I entered was private VLAN isolated, but I didn't add here the primary VLAN ID. If you want to explore the event logs, that is the show command, show event -R to start in reverse mode and have at the top the latest message. And then -D is for the daemon that you want to look at. And finally, the daemon that you want to look at is VLAN D. Then the debug log, if you want to debug PVLANs, just turn it on by writing debug, pvnet, and all. And then you can show the debug buffer, or you can redirect the debugging to another method. So for example, you can do that, send it to the console, you can send it to a syslog server, etc. And here you see that in the show events, you have the same issue we had before. VLAN 1130 is down due to pVLAN misconfig. And then we have something similar in the debug buffer. pVLAN handles VLAN or secondary VLAN misconfig, no primary VLAN association found. The diag dump will give you a lot of information, every information that is available on the private VLANs, and you may need to run this command if you have to escalate to our TAC. You collect this information and that's what you can share with them. And you can also share with the TAC the ShowTech private VLAN output, and you will find here a lot of very good information. So let's get to our demo. The layout for our demo is the following. We have a 6200 access switch where we have defined the primary VLAN in all the secondary VLANs. Then we have a promiscuous port that is actually a link aggregation group connected to our 6400 core. And there we have that same promiscuous port at the other end connected to VLAN 1100. That is our primary VLAN that is extending across. We have the VLAN interface, we have a router engine, and then we have a DHCP server here that will provide the IP addresses to our clients. In this case, the two clients are two instant APs connected to ports 7 and 9. Okay, so let me show you what I have here. On the top left, I have a 6200. That's where I'm configuring all the secondary VLANs, the primary VLAN and the secondary. At the bottom, I have a 6400 that where I'm only configuring the primary VLAN and where I have the VLAN interface for everything in that private VLAN. So, and then I also have a DHCP server connected there that is providing IP addresses to our clients connected to the 6200. So we'll go through all of that. On the right side, this is one of the IAPs. I told you that my clients are two IAPs, and I selected them for the how easy it is to get to the console. This is actually an SSH connection. So just seeing this here on the top right proves that I'm connecting from this VM all the way through the network to that IAP that is connected to a certain VLAN, and that is a community VLAN, and I'm coming through the whole network, getting through the private VLAN interface into the primary VLAN, from there crossing to the 6200, getting to the community VLAN or the secondary VLAN and out through that port and back with that ping. So actually with the teraterm connection, and then the pings that you see are between this IAP and the other IAP. Both of them are right now on a community VLAN so they can talk to each other. So what I will do throughout this is I'll show you first the configurations, Then I'll show you what happens when I move one of them to another VLAN and what happens to that ping. And then I'll also show you some inconsistencies so you see the beauty of that command. And that will be it. So let's get started with the configuration. Show running private VLAN. And you see this is extremely simple. Let me do the same down here. Show running private VLAN. So first of all, I have VLAN 1100 is my private VLAN, and it's the primary. Inside that VLAN, I have VLANs 1111, 1112, 1121, and 1122. 1111 and 1112 are two community VLANs, while the other two, 21 and 22, are actually isolated VLANs. In the real world, you would need only one isolated VLAN per primary because they're isolated anyway. But community VLANs, you may have more than one. So those would be like the usual deployments. Also see that VLAN 1130 has been defined as isolated, but it is there without a primary VLAN, so we'll see the effect of that later, how that is failing to work. Then I have interfaces 7 and 9 that are my secondary VLANs. They're both on VLAN 1111 at this point, and this is, remember, that is a community VLAN, and this is why we're having this ping right here, because these two ports and the two IAPs connected to those ports can talk to each other because it's a community VLAN. Then I will move one of them to another secondary VLAN, and we'll see that that communication will break, and then I'll put them both in an isolated VLAN, and we will see that it still doesn't work. The other thing that you see here is that I'm configuring the secondary ports and the promiscuous port. The promiscuous port, as we said before, in this case is a link aggregation group, and it is connected to the 6400, where I have VLAN, the primary VLAN only. I didn't define and configure the secondary VLANs up here, and because this is the typical deployment, and I have the interface lag 62, which is the same that I had here as promiscuous, and it is also configured as promiscuous. And this is key. This is one of the things that I told you that you have to check. That if you have here this lag in both places, and you have that VLAN one, that primary VLAN allowed on both of them, on both sides of that link, they're either both promiscuous or they're both regular trunk ports for that VLAN. So the promiscuous aspect here has to be on both sides. Now, let's take a look at the next step. Let me show you here on the 6400 the VLAN interface. Show run interface VLAN 1100. And you see I have there my default gateway for my client. So these two IAPs are actually seeing this IP address as their default gateway. It's also being routed using OSPF, and this is how I can reach from my VM here all the way to my IAP, and I'm able to get to its SSH interface. Now, let me take a look at the DHCP server. So show run, and we'll get to the bottom of this. And here you are. So we have the DHCP server VRF default, a pool that I called V1100, and I have the range of IP addresses. And notice that this device is on the host number 12 of this range, and it's pinging host number 13 on that same subnet. And notice that the default router that they're getting is actually the VLAN interface that we just saw. And then I enabled the DHCP server, and it's providing the IP addresses for this. Let's check that. So DHCP server leases. And there you are. So you see that I have these two MAC addresses here, actually these two MAC addresses here, the client IDs, and I am providing with this DHCP server the IP addresses for them. This one up here that we're seeing in the Teraterm SSH connection, 110.12, and also .13, which is the other IAP that I'm pinging from here. So now let's take the next step, which is let's see, let's verify that these two IAPs are connected to the right port. So show LLDP neighbors 1/1/7, 1/1/9. And you see on port 7, we have this IAP. And the IP address is the one that we are seeing here in the DHCP server. So that has worked fine. Let's take a look at the next one. And you see that on port 9, we have the other IAP, and it receives the IP address .13 from the DHCP server, and that's what we're pinging here at the other end of that conversation. So the next thing is, let's start moving the clients. Let's start looking at what happens is if I move one client to another secondary VLAN. Config interface 1/1/9. So run current. And you see that this device is on VLAN 1111, which we said was a community VLAN, and it's the same VLAN that we have for interface 7, and this is why they can talk to each other without routing. So now what I will do is I will say VLAN access 1121. So I'm moving this to another VLAN, in this case an isolated VLAN. I do that, and let's see what happens on the right side to that ping. So you see that ping is broken now. So let's, you see this is not moving. Let me see if I can reset this. Let me close this one. Let's reconnect. So let's try pinging now. And as you can see, nothing is happening there. They are on two different sub VLANs or secondary VLANs, so there's no communication between them. Now let's move the other one to the same VLAN. And let's try now. So they're both on the same VLAN, but still there is no ping between because they are on an isolated VLAN. So we proved that when the two devices were on the same community VLAN, they could talk to each other. The pings came through. The other thing that we saw is that when they were on different secondary VLANs, and I didn't show you, but if they were different, but they were, even if they were two community VLANs, they would not be talking to each other. That is the port group or secondary VLAN level of segmentation. And then we put both on the same isolated VLAN, and we saw that there's no communication, which is the port level isolation or microsegmentation. So with that, we have proof that the private VLANs work. Also, we have proof that the DHCP server works fine. And I won't show it here, but if you configure security on these two ports or on any port, you would see that it would work perfectly well. AAA, port roles, etc. All of that will work. So user roles, ClearPath, all of that authentication and authorization process would work. So there's no restriction in that sense. Now the next step is to check inconsistencies. So let's check if there are any inconsistencies on our 6200 switch. So show private VLAN inconsistencies. And it's showing me two of them. So there are two things. The 1130 is down, and the reason for that is that the VLAN has no primary VLAN associated with it. So let's show private VLAN associations. And you see that there's no primary VLAN for 1130. So that VLAN is down because of that. Now the next VLAN, 1122, let's take a look at its configuration. And so I shut it down. However, the primary VLAN 1100 has not been shut down. So the shutdown command has been ignored for this secondary VLAN. So those are the two typical configuration issues or operation issues. And you can get to them easily with a show private VLAN inconsistency command. So with that, we have completed our demo, and thank you.